Day 13 of 90, and today we kill a bug that compiles clean and ships to production. Picture this: you've got a bare enum for error codes, and somewhere a comparison checks error code equals 404. That HTTP status integer is completely unrelated, but the compiler says nothing. Your enumerator silently promotes to int, the comparison passes, and you find out in a postmortem. Enums and constants look boring until you realize how much of C++ correctness rides on them. Let's fix this properly. Here's the old enum color, red, green. The names red and green leak into the enclosing scope, and every value is just an int in disguise. So red equals 0 is true, color C equals some other enums value might slip through, and comparing two unrelated enums compiles silently. This is the implicit int promotion trap. In systems code where one enum means a GPIO pin and another means a register flag, that silent conversion is how you write garbage to hardware and spend a week bisecting. The fix is one word: enum class. Write enum class color, uint8_t, red, green. Now the enumerators are scoped, you must say color red. There's no implicit conversion to int, so color red equals 404 won't even compile. Comparing color to a different enum class? Hard error. The compiler now rejects exactly the mistake that used to ship silently. You moved a whole category of bugs from runtime postmortem to a red squiggle in your editor. That's the entire pitch. Now constants. Old C++ headers are full of hashtag define max_retries 5. The preprocessor has no scope, no type, and no respect for namespaces, it just does text replacement before the compiler ever sees it. If anyone else defines max, collisions. Worse, your debugger can't inspect a macro by name because it's gone by compile time. Replace it: constexpr max retries equals 5. Now it's typed, it's scoped inside its namespace or class, and the debugger shows you max retries with its value. Same compile time speed, none of the macro landmines. Constexpr goes further than variables. You can write constexpr functions that the compiler evaluates at build time. Need a bitmask helper for those GPIO pins? Constexpr uint8_t pinbit, uint8_t pin, return one U pin. Call it with a constant and it folds to a literal 0 runtime cost, but it's still a real typed function you can debug and reuse, not a fragile hashtag define pinbit, p1, p, that breaks the moment someone passes pinbit, a plus b, without parentheses. Type safety plus compile time evaluation. That's the combination macros can never give you. Here's where it gets real: controlling the underlying type. When your enum goes over a serial bus or into a pack struct, the byte layout has to be exact. Enum class opcode, uint8_t guarantees each value is 1 byte, not the implementation defined into plain enum might pick. Drop it in a struct, then prove it: static_assert, size of, packet, equals 4, \wire layout drifted \. If anyone adds a field or the enum's type changes, that assert fires at compile time instead of corrupting a frame on the wire. For ABI stability across a DLL boundary, this is non-negotiable. One more payoff: switch exhaustiveness. Write a switch over an enum class with no default, and compile with switch or wherever equals switch. Add a new enumerator next sprint, forget to handle it, and the compiler points right at the unhandled case. With a bare enum and a catch-all default, that new state silently falls through to whatever the default does. Enum class plus a defaultless switch turns I forgot a case into a build failure. Your state machines stay honest as they grow. So, enum class 4 scoped, strongly typed values that refuse to promote or cross-compare. Constexpr instead of hashtag define 4 typed, scoped, debuggable constants. An explicit underlying type plus static_assert to lock down memory layout on the wire or across an ABI. None of this is cosmetic, it moves integer misuse bugs from runtime to compile time, exactly where your hardware, protocol, and plugin code needs them caught. Day 13. Done. Stop trusting bare ints, let the type system catch the bug for you. Subscribe for day 14.